Friends, good day to all of SIDS and good day to my IRENA staff and colleagues. My name is Dake and I'll be your moderator today. And I'm following up from yesterday's webinar. And I want to welcome the participants back to the second and final day of the fifth webinar. Yesterday, we will have covered the difference between energy efficiency and energy conservation. And we would have also covered a few examples of how to calculate your consumption. And we looked at the utility bill. This morning, we have with us Vijay Mohan. He's also from the Terry Institute, and he holds a bachelor's in electrical engineering and a master's in renewable energy engineering. And he has over 11 years experience. I'll turn you over now to Vijay and he will present for you today. Feel free to interact, ask questions in the chat room, and I will address those questions accordingly. Vijay, over to you.
Thank you, Ellsworth, and good morning to all participants. So I hope you are able to see the screen. Ellsworth, can you please confirm the screen?
Yes, you can see the screen.
Okay, thank you. Yesterday we had the day one session, the basics of the energy, how different forms of energy is available, what is the differences between the energy efficiency, energy conservation, energy management, different perspectives and views were explained in yesterday's class. Today, and also some examples were, example calculations were also explained, taking an example of a school context. And today we will be seeing more into different steps need to be followed while assessing an energy use for any household or small commercial facility. And these calculations are very simple, designed in such a way that very easily it can be understood with a small mathematical formulas. And also we will understand with the different case studies how to calculate. So I will continue with the continuation from the yesterday's session. Yeah, that is day 2. So today we'll have a step-by-step approach to the home energy assessment. So what is an energy audit? It is a systematic procedure to understand where, how, and when the energy is being utilized. What is the pattern of energy usage in different facilities like house, take it as a household or commercial building, industry, anywhere. The systematic understanding of how we are using the energy can be understood based on the energy auditing process. And also through this process, we can understand where the actual amount energy is going waste and what is the quantity of energy that is going to waste. Okay, and this energy audit process will help us to understand how to reduce the energy usage and also how to use the energy in a more efficient way. So with the present context, we are concentrating more on home energy assessment, and electricity is the major kind of energy that is used to power all our household appliances, like for lighting, air conditioning, and other appliances such as refrigerators and electronic appliances like TV, computers, etc. So if you give a mathematical form of our energy usage or energy consumption, so we can give in the as shown in the below that f of energy efficient design plus efficient operations means this is a equation to define the energy consumption of a building. So energy efficiency is not just limited to smart use of appliances, but extends to installation of windows, roofing, and even landscaping. That is, proper architectural design also will impact on the usage of energy. So these are some of the 6 steps mainly to be followed under energy auditing methodology for household. Same methodology can be utilized for other applications, small commercial applications also, but for industries it will be in-depth, more in-depth. So with respect to household systems, we will see these 6 steps. So the first step is to identify the energy intensive appliances. Like each household will have a lot of appliances like TVs, fridge, kitchen appliances, etc., washing machines and all. So we need to make a list of all the appliances available in the facility, note down their energy consumption or nameplate rated power of each appliances, and make a list, and we based on that list we can get a preliminary idea on what are the major energy intensive appliances available in the household. Based on the available appliances, we also need to note down the number of hours that each appliance is being utilized daily. So when we multiply the rated power or the operating power with the total number of hours, we will get the number of units of electricity consumed in a day for each appliances. So based on that, we can understand which appliance is the major energy consumer daily. So accordingly, we can find out options. What are the available opportunities? Either energy conserving opportunities, energy efficient opportunities are available based on the usage and the kind of appliances available. We can try to find out in the step 2. Once you identify what is the existing appliances, what is the existing energy consumption, and what are the opportunities available to minimize the present energy consumption, we can try to calculate what is the annual energy consumption of present scenario and what is the annual energy consumption of the new scenario based on the energy saving opportunities available. Based on that, we can calculate the amount of energy that can be saved in a year. Next, when we have a total amount of energy that is saved, when we multiply that with the tariff rate, electricity tariff rate, that is 0.78, which we considered yesterday, we can try to quantify the energy saved in terms of annual energy cost savings. Next step, step 5 is for the identified energy saving opportunities, what is the cost of investment? Say, for example, if you replace a old television, which is a CRT based tube television with a new LCD based television TV, what will be the energy reduction? So those kind of things, and what is the cost of investment of the new one, we can identify in the step 5. In the step 6, we can calculate the simple payback period, which is the total amount of investment in terms of energy cost divided by annual energy cost savings. So this will give in terms of months or years how quickly we can recover our invested amount. So these are the 6 steps for doing the home energy assessment. So as I explained you, in step 1, we will be trying to identify the energy intensive appliances. So once you list down the energy different appliances present in your household, you can also make a chart with the name of each appliances, quantity of that particular appliance available. Say for example, lights, it is 5 lights or 10 lights, that one multiplied by the rated wattage. Also we can mention, and when we find out the number of operating hours of usage of these lights in a day, we can get the total amount of energy consumed by lighting lights in a day. So based on this formula, same thing was explained yesterday also with some examples. So this is energy consumption per month. That is number of days in a month we can multiply with the daily energy consumption to get the monthly energy consumption of that particular appliance. And when we multiply with number of days of number of months or number of days used in a year, we can get the annual energy consumption also. So in the first step, we are listing out all the appliances. We are taking out a number of appliances for each one, and we are trying to assess what is the daily energy consumption based on the operating hours. Then we are multiplying with the number of days in a month to get the monthly energy consumption, or number of days in a year to get the annual energy consumption. So that is the first activity we need to carry while doing a home energy assessment study. So every appliances will have a nameplate at different location of that particular appliance. Say for example, a microwave, bottom of the microwave, we can see this nameplate. That is microwave input power is 1400 watts and output is 900 watts. So whatever we are giving or we are measuring is the input power of any equipment. Okay, the output power depends on the efficiency of the equipment. So whatever we are measuring or taking down should be the input power. We can take this nameplate input power, or we can measure the rated operating power by using an energy meter. So different appliances will have different ratings, and those things can be, as a thumb rule, we can take the nameplate details, or if you have an energy meter, we can try to measure it with the help of an energy meter to get the actual operating watts or kilowatt. So once watt input power is equal to input watts divided by 1000 to get the kilowatt. So step 2, once we complete the process of step 1, that is estimating the energy consumption of each appliance present in the household and identifying what are the major energy intensive areas, we can try to identify the energy saving opportunities by these 3 broad categories. That is proper utilization of the equipment, that is energy conservation. One more thing is technology upgradation, which comes under energy efficiency upgrade improvement, and standalone power saving. This is also a behavioral practice which can be categorized under energy conservation opportunity. So based on the assessment carried out in step 1, we can try to look energy saving opportunities based on the categories, following 3 categories, like proper utilization of appliances, technology upgradation, standalone power saving. So we will see how it can be done in the coming slides. So step 3. So first thing is to calculate the annual energy savings, that is energy consumption with respect to the present operating condition of a particular appliance minus energy consumption after implementation of energy saving measure. The difference gives the annual energy saved. And in the step 4, we will be multiplying the annual energy saved with the electricity tariff cost. And in step 5, we are based on the if we based on the identified energy saving opportunities, we are also trying to find out what is the cost of procuring those energy saving equipment or appliances. In the step 6, we are calculating the simple payback period, that is investment divided by annual cost savings. We will get the period in terms of years here. So the payback period calculation is the main deciding tool to take a decision what kind of energy efficiency upgrades to be prioritized. So we will go step by step with different appliances available in a facility and try to find out what kind of energy saving opportunities are available. First one is energy saving measures in lighting systems. So generally in the olden days, and if you take 10 years ago, mostly fluorescent tube lights and also in some areas incandescent lamps were being used. And as a technology advancement, they are replaced with compact fluorescent tube lights. And nowadays, in the technology has improved further into, and the lighting semiconductor technology has come into lighting systems, and LEDs became the most popular, and their applications were reaching to each and every area of usage. So, for example, what kind of how to just know first what is the present lighting systems available in a facility. With respect to step 1, as I told you, we have to identify or calculate the daily energy saving, daily energy consumption of those particular appliances. Say, for example, a house is having fluorescent tube light, incandescent lamps with 3 and 2 numbers respectively, and their rated watts is 28 and 40 watts, and they are being operated for 10 hours and 13 hours respectively. So by using the formula which is mentioned below, and this is the same formula which is explained earlier also in step 1, so we can get the daily energy consumption, that is number of lamps multiplied by rated watts multiplied by operating hours divided by 1000 gives the daily energy consumption. And when you multiply the daily energy consumption with number of operating number of days in a particular year, we can we can get the annual energy consumption. So similarly, we can do for incandescent bulbs also. So based on the calculation, we are getting 686 units of electricity consumption per year. So that is the step 1 for lighting. So coming to step 2, identification of energy saving opportunities by means of proper utilization of the appliances, or by means of technology upgradation, or avoiding standalone power. So we need to look into those 3 categories to identify what can be done to save energy in this particular appliances. So first, as a first measure, it is mentioned is here, switching off lights when not using. So this comes under energy conservation opportunity. That means if at all then the daily operating hours is 10 hours, and you identify that based on the day-to-day practices, you are finding out that these lights in between for few hours or sometime it is being unutilized. Then when no one is available, it is better to switch off rather than just continue to run. So this is one kind of energy conservation opportunity as a behavioral change. So here also there is some opportunity of energy saving. So considering the same old examples, that is fluorescent tube lights and incandescent lamps. So if at all you are minimizing their operating hours by say unutilized hours per day for fluorescent tube light is 2 hours, and for incandescent bulb is 1 hour. So you are reducing the number actual operating hours to 8 in case of fluorescent tube lights and 12 in case of incandescent bulbs. So we can see that there is some sort of energy can be saved by just minimizing the operating hours. So with respect to the present or reduced operating hours, we can try to calculate the annual energy consumption. And I request participants to please calculate the annual energy consumption with respect to present scenario, that is reduced operating hours. You can just put it in the chat box. Your answer can be just mentioned in the chat box if anyone has calculated. So the first one is fluorescent tube lights. The present energy consumption is 245.28. It is correct. And the second one with respect to incandescent bulbs, it is 350.4 units per year. Whereas in our earlier case, we can see it is 306 and 379 units consumption. So the total energy consumption with respect to reduced operating hours is 595.6. So in earlier case, it is 686 units. So here straight away you are saving 90 units of electricity per year without doing anything. That is just by reducing operating hours during the unutilized hours per day. So this is one type of energy saving opportunity. So when you in the step 4, you are multiplying the energy savings with respect to the tariff, electricity tariff. So in this case, it is 0.78. You are multiplying 90.6 with 0.78 to get the actual cost savings, energy cost savings per year. So the investment in this case is nil. You are just trying to reduce the number of operating hours by turning off the lights when it is not required. So payback period will be immediate in this case. So this is one example to show based on the proper utilization of equipment or behavioral change, you can conserve some amount of energy by reducing the number of operating hours without doing any investment. So second example, as I mentioned, the technology upgradation and lighting has gone in a different way, and now LED bulbs are the most energy efficient lights available in the market. So as energy efficient retrofits, we can think of replacing the fluorescent tube lights and incandescent bulbs with LED bulbs. So the basic thing is for lighting, the basic terminology, that is to find out the efficiency of the light, it is called luminous efficacy. Is a measure which is giving the lumen per watt, means quantity of light emitted for a given input electrical energy. So that is the main deciding factor to actually replace your old conventional lamps with energy efficient lamps. So when 40 watt incandescent bulb is giving, for example, the luminous efficacy of incandescent bulb is just 50. So 40 watt incandescent bulb can give how many lumens? 40 multiplied by 50. That is 2000 lumens of electricity, 2000 lumens of light it can give for a input 40 watt of energy. Whereas CFL bulb of 12 watt can give the same lighting with 12 watts. And LED bulb is more efficient than CFL bulb, and it can give the same lighting in 7 watts itself. So the deciding factor to replace the old lamps with new lighting technology is based on the luminous efficacy, lumen per watt, which can be actually mentioned. The figure will be mentioned on the nameplate details of the product picture. This thing need to be calculated, and then only we have to come to a conclusion that 7 watt LED bulb is required to replace 40 watt, 10 watt is LED is required to replace 60 watt, etc. Similar procedure need to be followed for fluorescent tube lights or any other kind of lighting. Say high intensity discharge lamp like HPSV, mercury lamps. For anything, we need to find out first what is the luminous efficacy, that is lumen per watt of that particular volt technology, and for LED what is the luminous efficacy. Based on that, we have to multiply that luminous efficacy with the wattage of that light to get the total lumens that light can emit, and accordingly we can decide what is the energy efficient retrofit. So here, as an example to the fluorescent tube lights, same old example is shown here, and it is fluorescent tube lights and incandescent bulbs, 686 units of electricity consumption. If these lamps are replaced with LED lamps, say for example, fluorescent tube light, 28 watt fluorescent tube light is replaced with 18 watt LED tube light, and 40 watt incandescent bulb is replaced with 7 watt LED bulb. So if at all you are using the same number of operating hours, the daily energy consumption is reduced from 0.84 in case of fluorescent tube lights to 0.54 in case of LED tube lights, and 1.04 in case of incandescent bulbs is reduced to just 0.18 watts in terms of LED bulbs. So in this way, you are almost reducing around 400 units of electricity consumption. This is the replacing old lamps with energy efficient retrofits. So the investment, as a step 4, we will be calculating the energy savings, that is amount of energy saved in old scenario, that is 686, minus amount of energy consumed in present scenario, that is 262. The difference between the old scenario and new scenario gives the total amount of energy saved, that is 423 units per year. So as a step 4, we will be multiplying the amount of energy saved with the tariff cost, that is 0.78, we get 330 units, $330, and the investment required for the tube light, that is for each tube light, the price is around $52. So multiply that with number of lamps to get the total investment cost for replacing the fluorescent tube lights with LED tube light, that is $156. Similarly, we can get the investment cost for incandescent bulbs replacement with LED bulbs, that is $96. So the total cost of investment here is $252. So based on that, we can calculate the payback period, that is 0.76 years. That is the investment divided by the amount of energy cost savings, that is 252 divided by 330 gives 0.76 years. So that is how we can do the calculations for energy efficient retrofits for a particular appliance. So that is the examples for lighting. And now another example we will see this heating and cooling appliances. These are also major energy consuming areas in any household. We will be using refrigerators, air conditioning units, and also we will be using electric water heaters for water for our hot water needs, etc. So we will see what kind of energy saving opportunities are available in this category. So there are window air conditioning units, split air conditioning units, ceiling fans, electrical water heaters, etc. So each one has its own kind of power consumption depending on the capacity. So these wattages, what is shown here, may vary with respect to the size of the equipment and also different manufacturers. And we need to see this wattage based on the nameplate. We need to take based on the nameplate or based on the operating energy, operating load measured by a energy meter. So as a first energy saving opportunity for ceiling fans, the present technology improvement in ceiling fans is brushless DC motor fans. So brushless DC motor fans also looks like similarly to normal ceiling fan, but the amount of energy consumed in this brushless DC fans is almost 50% less when compared with the traditional fan. So this exercise is actually carried out in our facility as a demonstration purpose to see whether what is the different steps of usage, what is the amount of energy consumption or power consumption for each step, and whether the output, that is fan output CFM, is given or volume of air delivered is also in the same line or not. To check, we have done one experiment and it is almost equal, both the fans. The power consumption is almost 50 to 60% less when compared with the traditional fan. So these fans, brushless DC fans, comes with remote control to just bring some smartness in the utilization of fans. Like it has a timer, and also you can adjust the settings with respect to the remote control only. So by replacing these conventional fans with brushless DC fans, so we can also, this is an energy efficient opportunity where we can save a lot of energy cost here, operating cost can be saved. So for example, if you take the nameplate detail, that is 75 watt for conventional fan and 28 watt for BLDC fan, and the daily energy usage is 15 hours per day. So a regular fan is taking around 1.125 units per day for 15 hours usage, whereas BLDC fan consumes only 0.42 units for 15-hour usage. And similarly, if you are operating it for 300 days per year, then around 337 units of electricity is being consumed by the regular fan, and only 126 units of electricity is consumed by BLDC fan, which is straight away savings of $165. And the investment cost for each BLDC fan is $400. And based on that, we are getting a payback period of 2.42 years. So this is this much of an amount of energy can be saved in the DC fans replacement from regular fans. So similarly, air conditioning units. So a 1.5 ton window AC, if, for example, if you take, it is consuming a rated power of 300 watts. There will be a compressor motor inside this air conditioning unit, which will be switching on and switching off with respect to the desired room temperature setting. So when the compressor is on, it is around 1300 watts it may consume, or if you measure with a energy meter, it may consume even less also. So this is a since we can at most it can consume around 1300 watts. So when it is off, only the fan will be rotating, the indoor unit fan will be rotating, whereas the compressor motor will be switching off. So it will consume only very fractional kilowatt during that particular time. So the considering the ambient temperature and set temperature, the compressor inside the air conditioning unit switches on or off, and the energy consumption also changes with respect to that operating cycle. So in air conditioning units, we will see what are the type of energy saving opportunities available. So we will again look into energy conservation opportunities by proper utilization of equipment.
Vijay, just to explain, because I think sometimes people don't understand why air condition, they keep hearing the terms inverter type and non-inverter type. Just to explain why a non-inverter type will consume more. I see you have compressor on, compressor off. And what happens when the compressor is on is that you have an extra load, like what you call a starting current. So consider a person who's pushing a vehicle from standstill, and you push this vehicle, you require all the strength. So that's the initial load. And once the vehicle is moving, then you require less energy. But if you have to keep stopping the vehicle and then pushing it again, then you will have to keep this extra strength. And that's how the compressor looks at it. Every time it stops, it becomes an extra load. And every time it starts back, every time it starts, it's an extra load. And then you stop and then you start. So you're burning a lot of current because you're asking for what you call a starting current. So what you're aiming for is not to stop, but to actually slow down. And that is why you need the inverter type. I guess you'll explain the inverter type.
It's going to come in the next slide.
Right, but I was just trying to explain with a practical example why it is causing extra energy, extra power.
Okay, thank you, Elspeth. So as a first one is energy conservation opportunity. This is, see, normally for any household air conditioning unit, the set point can go as low as 18 degrees and to as maximum as 32 degrees. This will be the operating range of any particular air conditioning unit or household air conditioning unit. So normally, as per the research carried out by ASHRAE and all, the human comfort temperature is around 24 to 27 degrees centigrade. If you go below that one, it will be cooling. It is more cooling, and if you go above that one, it will be slightly hotter. So temperature is a degree of hot or cold. So in this case, for a human body, the comfortable temperature is around 24 to 27 degrees centigrade. So mostly in most of the areas, we will be seeing that the temperature of the air conditioning unit is set at 20 degrees, 22 degrees, or in some cases 18 degrees also, which is actually you are making the compressor to do more amount of work to deliver that much of cooling load. So when you increase the set temperature of a air conditioning unit, you are actually reducing the work done by the air conditioning unit, the compressor, so that it will switch on, switch off very limited times. So by doing that also, we can save some amount of energy in a day-to-day usage. Okay, that means you are reducing number of operating hours of compressor on, or number of times operating time of the compressor you are trying to reduce while increasing the set point of the temperature. That is, so as a thumb rule or based on the research done, by increasing the set point between 24 to 27 with respect to 20 degrees or below 24 degrees, at least 3 to 4% of energy can be saved. So savings in lower temperature, that is below 24 degrees, you are setting to 24 degrees, it will save around 6% for every rise in 1 degree centigrade. And higher temperature settings, greater than 24 settings, 4% for every 1 degree centigrade. Means between 24 to 25, 27, that in that particular time, only 4% of electricity can be saved for every 1 degree rise in set point. So for example, we can discuss about a 1.5 ton window AC and its rated power is 1300 watts per hour. We can say 1300 watt is the rated input power. AC will operate for 10 hours in a day and electricity cost is 0.78. So with respect to increased set points 27, 24 and 18, we can see what is the quantity of energy consumption per day. This value can be based on the measurement using a energy meter. At 18 degrees, if you set a air conditioning unit and if you operate it for 10 hours in a day, you are consuming around 13 units per day. If you are setting that air conditioning unit at 24 degrees centigrade and you are operating at for 10 hours, you will be consuming around 10.5 units per day. And if you are setting at 27 degrees, the it is consuming around 9 units per day. So you can see when you increase the set point of the thermostat of the air conditioning unit, you are able to see the reduction in energy use, energy consumption. So the difference is giving the cost savings by multiplication with the tariff cost, that is 0.78. And if you multiply with number of days in a year, say for example 365 days, you will get the total annual energy cost savings per year. So here you can see that with respect to 18 degrees set point, if you set the compressor at 24 or air conditioning unit at 24 degrees, you will be reducing 19.2% of energy consumption. If you set it at 27 degrees, you will be reducing around 30.8%. So a significant amount of energy can saved when you set the temperature setting of the conditioning unit between 24 to 27. So this is one kind of opportunity available in air conditioning units. So here one graphical illustration is shown with respect to temperature set point for every 1 degree, 18 degrees to 27 degrees, and energy consumption per day. This is also based on experimentation. These figures were achieved with respect to Indian climatic conditions. So a increase of AC temperature set point from 18 degrees to 24 degrees can help to save around $730 in a year, and increase of AC set point temperature from 18 degrees to 27 degrees centigrade can save around $1,168 in a year. So this energy consumption figures can also change with respect to different climatic conditions of different geographical locations. So this one is actually for Indian location only. So also, if at all you might be feeling hot when you set the temperature at 27 degrees centigrade, in that case, to circulate that cool temperature properly, we can also switch on the ceiling fan with optimal speed so that the air circulation in the room will be proper. And just a significant small quantity of energy only will be increased to operate the fan at optimum speed or low speed. So one more energy saving opportunity is always set the timer to automatically switch off AC after certain duration of time. So this will be applicable for areas where Normally, if you see summer conditions, the days, the full day will be very hotter, and evening time the heat will continue till midnight, and by morning it will become normal ambient air condition temperature. So if at all we are in a case one, we can see that AC switch on time is 8 p.m. to evening 6 a.m. So in case two, we are trying to use a timer to switch off the AC at 4 a.m. so that you are reducing the amount of operating hours by 2 hours. So by that you can also reduce the energy consumption. So same thing is explained here. The cost of operating for that particular period is also coming down based on the reduced operating hours. So here also you are saying saving around $168 per year, and also without any investment. So one more opportunity is always keep the outdoor units in a shade and ventilated area, so that this measure also will help in reducing the withering of the system in the based on the direct sunlight or rainy season and all. And also when you keep it in a shaded condition, the heat dissipation or the heating of direct heating of the unit also will come down. That means the radiator is actually dissipating some heat. It will dissipate the whatever heat it is taken from the inside room, and it will dissipate directly without gaining the ambient air heat also, when you keep it in shaded condition. In that way, some small amount of fractional energy saving also can be achieved in that one. But beyond energy saving, it will also help to save the unit from direct ambient conditions. So coming to the energy efficient technologies available, we are discussing about the old air conditioning units, which are window units or split ACs, where there is no inverter present. And the latest units are coming with inverter driven brushless DC unit only. So that means it is actually saving around more 50 to 60% of energy cost is actually reduced directly. And based on the operation, like how Elspeth has explained in the previously, that a non-inverter AC unit will be taking a lot of energy to switch on, switch off multiple times, so that the cumulative energy is actually increasing to do that kind of work. Whereas the inverter driven air conditioning unit, with respect to the set temperature, it will reach up to one speed and smoothly operates in that range to give the temperature, say plus or minus 1 degree with respect to the temperature set point. So in that way, inverter air conditioning units by technology itself, they are energy efficient, and also they are energy efficient by means of operation, operating it at optimum speed. So thus energy can be saved in this replacement with old non-inverter based unit with energy efficient inverter based unit. So a sample example is shown here with 1 tier air conditioning unit, which is old and non-inverter type, which is consuming around 1184 units, maybe rated wattage, and monthly energy consumption is around 93 units. Whereas inverter AC unit rated capacity itself is 840 and the monthly energy consumption is around 65 units. So the difference of energy between the old and new is around 28 units. And with respect to annual usage, say for example 200 days you are using, or number of days, you will here 336 units is the annual energy saving achieved, and multiply it with the tariff cost, that is 0.78, to get the cost savings in dollars. So the investment for the new inverter driven air conditioning unit will be around $3,000, and that divided by the annual cost savings will be 11.1 years. So here this 11.1 years of is a very high payback period. That means you are putting for the utilization of your equipment. That is, since you are utilizing the conventional or old unit for a minimum period of time, your savings is also less if you replace with a inverter driven unit, which is having a high investment cost. So this example is helping us to understand that if you are using only minimum operating hours in a particular month, and that air conditioning unit, if you are replacing with energy efficient inverter driven air conditioning unit, which is very high cost, your payback period goes very high. That means your energy cost savings recovered is going to up to 11 years. But if at all you are having an application where you are using this old air conditioning unit for 24/7 and 365 days, if you are using, in that particular case, the payback can come within 2 years or 3 years, because you are increasing the operating hours of the unit. So in that particular case, these energy efficient air conditions are give a significant amount of savings. So this is one particular case. So fourth opportunity of energy saving in air conditioning is reduce the heat load of the room. So ambient air condition and the aesthetics or design of a room also will help in changing of energy consumption or use. That means if at all your room is having a lot of ambient light coming in, and also the temperature, the windows are not properly insulated, that means you are increasing the heating load of the room, which is actually impacting the compressor operation of your air conditioning unit. That means it is trying to do more work to cool the room because of the added heat from the ambient conditions. That means we need to properly insulate any air conditioned space, and also we need to have false ceiling to the air conditioning space, so that you are actually reducing the volume of the room, so that the compressor of the air conditioning unit will do less work to cool the limited volume of the room. If the volume of the room increases also, it will take more time to cool the room, and it will increase the more energy consumption. So that is also one thing to consider. So you can either put curtains on the windows, or there are some coatings, special coatings that are available currently, which we can apply on our glass windows, so that it will reduce the heat gain inside. So close doors and windows for a air conditioning space, arrest air leakages near doors and windows, avoid ironing of clothes in air conditioning rooms. So these are some of the tips we can follow to optimize the heat load in the room. Always keep units serviced and clean. That means as per the vendor specification or original equipment specification, we need to clean the outdoor units, the radiator every 6 months. If at all any dust accumulation is there, we need to clean. Otherwise, the refrigerant in the outdoor unit will not get cooled, and it will actually increase the load on the compressor also. That also will help in impacting the energy increase. Monthly cleaning of air filters with improved performance, and will improve performance and lifespan of the air conditioning unit, and also save some amount of energy. So coming to heating appliances, replace electric water heater with solar water heater or gas water heater. So normally we use electric water heaters, which is very simple way to use the in every household. But whereas there are some energy saving efficient technologies available, renewable energy technology is available to use the sun to heat the water and use that hot water for our day-to-day use by storing in an insulated storage tanks. So, and also gas water heaters is also efficient than electric. Why? Because you are actually, see, by means of gas, you're running in the power plants to produce electricity where some kind of loss is happening. And that electricity we are again using to produce the hot water. Instead of that, we can use the LPG gas directly to heat the hot water, where some quantity of say losses in producing the electricity by the power plant is also reduced. So that is a related to overall energy scenario. So, but normally gas water heaters are more efficient than electric water heaters. So convert electric water heater convert electric energy into heat energy. It is easy to install, it is less expensive and requires less maintenance. Operating cost of these electric water heaters are high and don't give instant hot water. Whereas gas water heaters use natural gas or LPG, and this combustion produces heat energy. It provides instant heat, cheaper to run as gas is cheap, hence suitable for large families. It releases carbon monoxide in some cases where the combustion doesn't is not happened properly. That is one drawback of gas-based heaters. And nowadays, with increased fuel costs, this is also not becoming very attractive. And one most attractive option is solar water heaters. The light radiation from the sun is converted into heat energy. Operational cost is zero as sun rays are free. Hot water is available even during power cut. That means this hot water will be stored in some insulated tanks, and that will actually save the heat gained by the water. And nowadays there are some electric heaters also installed in this solar water heaters as a backup. That means whenever there is no sunlight, the electric heater also can switch on and heat the water inside for our requirement. And it needs additional roof space and also requires annual maintenance. This is one additional cost for solar water heaters. So the solar water heater constructional and different parts available is explained here. It is having a vacuum tube, evacuated tube, where from the bottom cold water is taken. Based on the thermosiphon effect, the water from the bottom is getting heated, and by means of thermosiphon effect, it will flow into the top hot water storage tank, and that hot water is stored in that tank. And also top in the tank only some electrical heater also can be arranged as a emergency requirement during non-sunny days. So some of the opportunities available in kitchen we will see here. So normally in kitchen we use refrigerators, toasters, rice cookers, kettle, induction stove, microwaves, etc. These wattages may vary with respect to different capacity and different brands of this equipment. This is just for given as an indication here. So types of cooking. So gas-based cooking. This type of cook stoves has a burner on top and uses gas to cook food. Electric. This type of cook stove has a coil that heats up due to resistance when current passes through. As the name indicates, it uses electricity to generate heat and cook food. And induction cook stoves. Also, this type of cook stoves use electricity but uses a magnetic property of steel to directly heat the cooking vessel, cooking quantity or item in the vessel. Unlike other cooking methods, it does not use flame or red hot heating element to cook. Thus, it is considered more energy efficient than the conventional electric stoves. Also, it only heats the vessel inside the vessel contact, thus reduces possibility of injury. So efficiency of gas heater is around 40%, electric is around 74%, and induction stoves are around 85% efficient. So energy saving opportunities in refrigerators. So some of the things are mentioned here. Means these are the things we should consider to minimize our energy consumption in refrigerating systems in kitchen. So do not open and close the door very frequently or keep it open for more time, as the coldness inside the fridge will escape, and again the compressor will take more energy to cool the space inside. So do not overload the refrigerator. That means you should not keep the items inside the refrigerator beyond the capacity, or you should not keep hot or warm food items inside the refrigerator. Cover lids and wrap food stored in the refrigerator. Uncovered food release moisture and makes the compressor work harder. That means it will make the compressor to work more. Leave enough space between your refrigerator and the wall so that air can easily circulate around the refrigerator. That means there is a radiator behind the refrigerator. When there is a proper air circulation only, it will get properly cooled. Otherwise, the heat dissipated by that radiator will not escape properly, and again it will increase the load on the compressor. Don't keep your refrigerator or freezer too cold. There will be a seasonal setting, summer, winter, monsoons. So with respect, we need to go make the setting with respect to the seasonal setting. That also will increase some quantity of energy, like how it was explained for air conditioning unit settings. That means you are reducing the operating load of the compressor. So energy saving opportunities in other home appliances. So we will see what is there here. So coming to electric iron, select iron boxes with automatic temperature cutoff. I hope most of the systems are with this setting in the present scenario. Do not put more water on clothes while ironing. That means we will be there will be steam iron boxes which will actually give the steam and we can iron the clothes properly. But sometimes when that option is not there, we will try to sprinkle some water on the clothes, which will actually increase the load. That means it will reduce the temperature of the heating element, and again here the iron box will try to increase to the set point, and this way it will be working more. And also do not iron wet clothes. That is also one area we should understand. Washing machines. Run washing machine only with full load. That is optimum utilization of the equipment. Use optimal quantity of water and detergent. Use timer to save energy. Prefer natural drying over electric dryers. So when there is a good sunlight, natural drying is obviously preferred. Mixer grinders. So dry grinding in food processor takes longer time and consumes more energy than liquid grinding. So normally when we are grinding dry items, or they are some dry leaves and all, it will be simply rotating and they will not get grind properly, and we are using more energy to grind them. If it is a wet mixture, it will grind very quickly. So that is also, that means you are making the motor to work less time. Less time indicates less energy. So the third option is standalone power saving. Under standalone power saving, we use electrical power that a device consumes when not in use, but plugged in source of power and ready to be used. That means mostly in our day-to-day household appliances, we use so many electronics appliances where we use a remote control to switch on, switch off. So TV, for example, TV is off with remote, but main power switch supply is on. This is one place where standby power is being consumed. TV is off, but setup box is on. Not using microwave, but it is on from main power supply. Not using internet, but modem is on. So these all are the areas where some amount of small fractional quantity of energy is being wasted. And if you see, if you multiply with the number of hours and number of days in a year, you will see the significance of energy being wasted, or energy cost being incurred in this kind of standalone power. So these are some of the examples, like a DVD player will consume around 10 watts standby power, microwave 5 watts, desktop computer 9 watts, cable setup box 10 watts, audio system 24 watts, television 7 watts. So these are some of the typical standby power consumptions. In a survey, it was found that in 85% household setup boxes, in 85% houses, setup box and TVs were not switched off from the main supply during night time. That means we are just switching on with switching off the equipment with the remote, and we are not switching off at the main supply. That means the standby power is getting consumed. It was also found that in 30% houses, computers was not switched off from main supply after use. So this is also a same case where energy is being wasted. So just to quantify this wastage with respect to in a year, that is 365 days, and a number of hours of usage per day, or number of standby ideal time of these equipment on per day. So we can see that a significant energy is being wasted in these equipment. That is 58 units per year is wasted for setup box, 41 units for TVs, and 45 units for computers. So that means we have an opportunity to minimize this much quantity of energy wastage by switching off the equipment from the switch itself. Remove the plugging. So one more opportunities are explained here. In most of the countries, 220 or 110 volts is used as the domestic voltage, and mostly we use if at all, say for example, we buy American equipment where the frequency is 60 cycle, and in other locations the power frequency is 50 cycles, and in that case we will use cyclo transformer, and also voltage also will change. And for that we use a dry type transformers to change the frequency as well as to change the voltage. So such kind of transformers, they will change the power to our requirement, but they come with some cost, at the cost of some energy loss. So normally transformer losses, normal no load losses are also called as core losses. It is the power consumed to sustain the magnetic field in the transformer steel core. It occurs when the transformer is energized. It does not vary with load. So now in transformer there are two type of losses, that is no load losses, that is which is happening in the iron core as shown in the picture, mainly to magnetize that iron core. Another kind of losses available is based on the transformer winding, which is shown here, high voltage side and low voltage side, which is a copper winding. There copper losses will take place. It varies with respect to the load being applied on the transformer. So it is the primary, it is the power loss in the primary and secondary winding of the transformer. It is associated with full load current flow in the transformer winding. It varies with the square of the load current. So here in the picture, it can be seen that the core losses are constant losses then they don't change with respect to the loading capacity of the transformer, whereas the copper losses changes with respect to the loading capacity of the transformer. So these losses data will be provided by the supplier on the test certificate. So some of the typical efficiencies of these transformers are listed here. Minimum efficiency requirement for low voltage dry type transformer as per US Department of Energy. Low rating transformers has low efficiency. In home, generally 1 kVA or smaller size transformers is used for 110 volt appliances. Hence losses in smaller rating transformers is around 2.5 to 3%. After using the 110 volt appliances, disconnect the transformer from main supply to save standby power, that is no load power also. So there are the chart is shown here has transformers of rated capacity 15 kVA to 1000 kVA, and their efficiencies are also shown here. So to meet the appliances rated voltage and frequency like 110 volts and 60 hertz, which are imported from US or any other locations, smaller rating transformers are used in households. So the losses of these 1 kVA, 2 kVA, 3 kVA, 5 kVA transformer, which are the most generally used capacities, are shown here. So the copper losses are in the range of 3% to 1.5%. That is 30 watts to 75 watts. Whereas, no, that is core losses. Whereas the copper losses or the winding losses is in the range of 30 watts to 100 watts. So fixed losses in the transformer takes place if it is charged. Whether you are applied load or not, these fixed losses will consume invariantly. And with respect to applied load, the copper losses will be consumed, which is an addition to the fixed losses. So typical energy loss per day in a 2 kVA transformer without you applying any load, if you just to keep it switch on, it is 960 watt hour per day. That is 1 kilowatt hour is being wasted if you just to keep that 2 kVA transformer in switched on condition without using any load. That means it is better to switch off the transformer also. If same transformer is in on position for a month, the fixed loss is going to 29 units. It is just multiplication of daily energy loss with respect to number of days in a month to give the monthly energy wastage. So the total losses of a 75 kVA, 30 kVA, 5 kVA transformer is also shown here. That means the sum of no load loss and load loss is shown here. So total fixed loss in a dry type transformer is around 2.2 kilowatt. Annual fixed loss in dry type transformer is around 19,272 kilowatt. That is with respect to 75 kVA transformer. It is explained here. That means here it is mentioned that we need to actually utilize this cycles transformer also with respect to the load being used, that is appliance being powered. When you switch off that, when you are not using that appliance, it is better to switch off the transformer also. That thus you are saving some quantity of energy. So this slide is showing here how to shop for and identify energy efficiency devices, equipment and appliances. So this is a selection criteria which we need to think of while buying a energy efficient appliances or any new appliance. So the first point is pick up the right size. That is running a large mission. Even the most energy efficient one uses more electricity than a compact one. So don't buy something bigger than what you need. Check energy savings and settings. Energy saving settings. Appliances like dishwashers and washing machines often have energy saving settings. So we need to understand those settings and utilize them properly so that we can save some quantity of energy while utilizing that equipment to its full extent. Read the energy guide label. When buying home appliances, look for the energy guide label. These stickers indicate the efficiency statistics for the appliance as well as the estimated operational cost and energy consumed. These stickers may also indicate the amount of money and energy you can save over the appliance lifetime. Prioritize. Energy efficient appliances may be more expensive or compared to others, but there is a myopic view. When you are buying appliances, look at the long-term impact such as how much money you will save, then prioritize the appliances you need to invest in to maximize your savings. For example, you are saving more by replacing a old refrigerator than you could by replacing an old toaster. This is with respect to equipment you can prioritize, and also with respect to number of operating hours also we can prioritize. That is, if you are operating equipment for 24/7, it is very appropriate to replace that old 24/7 operating equipment with latest energy efficient equipment. Because as we saw in earlier one example, if you are replacing an equipment with limited operating hours, because of the high cost of the energy efficient applications, it may not be an attractive payback. So it is better to replace with respect to operating hours also. So this is energy labeling. Like in US, we can see Energy Star labeling, or some of the electronic equipment we see. And in India, we can see this Bureau of Energy Efficiency has given this star labeling, which will define the efficiency of that particular appliances. When you shop for a new appliances, look for this endorsement label. These labels are present on all qualified products that meet specific standards for energy efficiency. Look for the label on home appliance, electronics, water heater, and other products that consume energy. These electrical energy. These products usually exceed minimum performance standards by a substantial amount. So the following are some of the endorsement labels of some countries. Like Energy Star is an international standard for endorsement of energy efficient products. This program is also used in Japan, Switzerland, UK. So BEE has given the Indian Star labeling system. So these are some of the labels where we can see on some of the appliances in different countries. This is an informative label. These labels provide information on energy consumption, energy efficiency rating, and operating cost. It does not give any comparison to other models in the market. That means it is not comparing the same kind of equipment, same capacity of equipment with other thing. It is actually comparing its previous version, that is old efficient version, with the present energy efficient version. So on the label, if you take this energy guide label of US government, there are 6 items shown here. So item 1 is the maker, model number, and size of the appliances. It gives those appliance details. Energy, number 2 is quantity of energy cost savings in a year. So it varies with, they have already also given some cost range of similar models also here. That means it is comparing with similar models where this model stands. And number 3 is, as I explained, the cost range, which will help us to compare the energy use of different models with same features also. And number 4, the Energy Star logo shows that this model meets the criteria of energy efficiency. And number 5 is estimated yearly electricity consumption. So that consumption, when you multiply with the tariff rate, you give the energy cost also. And number 6 gives the key features of the appliances. Like here on the top left, it is shown that refrigerator, freezer, automatic defrost, side mounted freezer, through the door ice. So these are some of the features. So that features are also mentioned in this guide or label. So this comes to an end of the day 2 slides. If any doubts or clarifications, you can please raise. Thank you very much. Hello. Hello. Ellsworth, are you there?
Yes, I'm here.
Yeah, please.
Sorry, I didn't hear you. Sorry.
No, this came to the end of the slide. So if any doubts or clarifications, I can take up now.
Oh, okay. Well, thank you, Vijay, for the presentation. I think you provided a lot of good examples. I didn't get much questions from the participants. So I want to reach out to the participants at this time to see if you have any questions that you would like to pose to VJ. Any questions, even if it wasn't related to the presentation? Any concerns that you had in terms of energy efficiency? We still have a few minutes and we can take some questions. Vijay, I had a concern. Can you go back to the slide regarding the transformer losses?
Yes, just a second.
No, not the one.
Yep.
The one after this. No. Yes, this one. Okay, so the core losses in this particular site, this is the losses at no load?
Yeah, no load is core losses and winding losses are copper losses. That is load losses.
Okay, so you're saying that a 5 kVA transformer will lose
Around 75 watts of
5 kVA transformer has about 3.5% losses at full.
1.5.
Well, no, I'm combining the 1.5 plus 2.
Yeah. That is the total losses. Yeah. That means when we are utilizing this transformer at 5 kVA full capacity, the total loss will be around 3.5% of 5 kVA.
Do you have an example in terms of using the tariff just to show the participants right to the 18?
So actually
18,000.
yes. So that's what here I have shown this example. Energy loss per day in a 2 kVA transformer without appliance in use is 960 watt hours.
Yeah.
So if you multiply that for the number of days, it is around 25 units. When we multiply with the tariff by 0.78, for example, it can give around $20 is the cost lost, energy cost lost.
Per month?
Yes, per month. That is for a 2 kVA transformer whose losses, core losses are 40 watts.
Yeah. That's a big number.
That's what, when we see the losses as a fixed figure for 1 hour, it will be very small. But when we multiply or combine with number of hours and number of days of usage in that condition, it will give us a big number, and that will actually show the significance of the cost is lost in operating in such manner, which gives us an opportunity to save.
Yeah. Nadia, do you have any questions, any concerns, any comments? Okay, well, I want to thank you, Vijay, and thank your colleagues from the Terry Institute, Dr. Rao and Sharma from yesterday. I want to really thank you for being with us over 5 seminars. I think it is quite informative, and we really appreciate the effort that you will have spent preparing these slides. I want to thank the participants as well from various parts of the SIDS. I know it's not For some of you, it's perhaps in the night. For me, it is early in the morning. And I know it is an effort. And I want to thank you for participating. I want to thank the team from IRENA, who will have coordinated this effort and the initiative, and Nadia, and thank you. And I would like to officially end this webinar. The presentation will be available online. I think that was posted, a link. So you can view the webinar and see the PowerPoint slides. And I want to officially end this webinar. Thank you, everyone, and have a good day.